How's it going, you guys? In this video, we are going to be talking about reciprocal or rational functions. The reciprocal function is 1 over x. This could also be written as x to the negative first. Depending on who you talk to will depend on what they call it, whether they call it a reciprocal or a rational. In pre-calculus, we call it rational functions. In Algebra 2, a lot of the times they call it reciprocal functions. But essentially, they're called reciprocal functions because if I take the x values of like 1/2 and I substitute it into this equation, this -1, remember, just means to take the reciprocal of the fraction. So if I take the reciprocal, then my y value is 2. 1 over 1 is 1. 1 over 2 is 1/2. So if I have 1, 1, 2, 1/2, 1/2, 2, this function, you saw it a long time ago on the very first day of school. This function looks like that. We also have on this side, where it would be at -1, -1, and it gets closer to our x-axis and closer to our y-axis. So now, those things that they are getting closer and closer to, the very first thing that's getting closer to is our horizontal asymptote. Well, I mean, it doesn't have to be first, but it's getting closer to this. So as it goes out in both directions forever, notice in the left-hand side, it's getting closer and closer to that y equals 0 line. As it goes to the right, it's also getting closer and closer to that y equals 0 line. Another thing that it's getting closer to is our vertical asymptote. So notice as it goes up and down, so it's going this direction, it's getting closer and closer to when x is 0. It's going that direction, it's getting closer to when x is 0. So those are the main things that we are looking for. If I were to list the domain and range of this thing, for the domain, it's going left forever, so it's coming from -infinity. And then it goes all the way up to 0, but it does not include 0 because we have an asymptote at 0. So I kind of stop it at 0. Then we have or, the little union symbol. It goes from 0 to infinity. So it's that whole interval. And the range is actually the same thing in this one because for our least y value, it's coming from -infinity. It's going up until our asymptote at 0. And then it goes on from 0 to infinity. And that's kind of all the characteristics that we are going to be looking at in these types of functions. Something else you could see, notice in this one, whoop, 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 we have a 2 on top. So now if we have a 2, essentially what it is going to do is it's going to affect the curvature of our graph. So if I could look at kind of those same points that I looked at in the beginning one, say I have 1/2, 1, and 2. 2 divided by 2, and it's negative, well, that would be -1. 2 over -1 would be -2. And then 2 divided by 1/2, essentially -4. So it's just making it go up a lot faster, but what it's also doing is it is this negative, if you remember back from when we have negatives in front of things, for graphing, what this does is it reflects everything over our y-axis. Sorry, it makes all the y's negative. Makes all the y's negative, so it's reflecting it over the x-axis. My bad, my bad. I'm so sorry. 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right. So for the graph of this thing, I had 1/2 -4. So I have about right there. And then I have 1 -2, so I have about right there. And then I have 2 -1, so I have about right there. So this is similar to our other one, but it is just growing a lot faster. So as it grows, or sorry, this 2 is also, so I could look at this as -2 times 1 over x. So what we're doing is we're multiplying our y's by -2, if you remember your parent function. We will get more into this in class. I will talk to you guys a lot more about this in class. So if our parent function had the point 1, 1, if I multiply that by -2, -1 times -2, right here, right there, that point, -1 is the y value, times -2 is 2. So it'll do the same sort of deal in this direction. It'll get closer up here, but it is reflected over the x-axis. For our asymptotes, this did not move up, down, left, right, anything like that. So they stay exactly where they are. Our horizontal asymptote is still at y equals 0. Our vertical asymptote is still when x equals 0. The domain and range have also not changed in this thing. They're going from negative infinity to 0 and 0 to infinity. All right, let's look at another. All right, I'm going to share with you in this one the way that I look at these things. So kind of like what I was talking about in the last one, I know my parent function of the reciprocal is 1 over x. That parent function has points here, has points there, and I know it gets closer to my asymptotes in either direction. So there is kind of our parent function right there, where I have the point 1, 1, I have the point negative 1, negative 1. That's really all that I remember. Well, all that I force myself to remember. You can remember more, but this is all I use in order to graph these things. So now, this negative 5, in order to get a negative 5 there, what I had to do to my parent function is I had to multiply it by negative 5. So what that tells me, just like in the units before this, is I am multiplying all my y values by negative 5. So if I go through, really I'm only forced to look at these points. So if I have a y value of 1, if I multiply 1 times negative 5, it is now right there. If I have a y value of like 1/2 right there, 1/2 times negative 5 is like negative 2.5. So what this tells me is I am reflecting over the x-axis. I did not move up, left, right, down, anything like that, so my asymptotes will stay exactly where they are. We'll see one in just a minute where it doesn't. But I know I'm going to get closer to the asymptotes as I go out. So now this point at negative 1, if I multiply that by negative 5, so that's what I'm doing, multiplying the y's by negative 5, it's negative 1. So times negative 5 would be positive 5. So I know it'll do sort of the same thing, and that it reflects over the origin. So this would be the graph that I would be looking for, something to this effect. Whether your curvature is exactly right, I'm not going to be checking as much on that, but I am going to be looking for the right shape. As far as this needs to be down here, this needs to be up here, where they're getting closer to the asymptotes in either direction. All right, look at another. All right, here's one where some things are going to be moving around. So again, my parent function is just 1 over x. Just like everything you've done before, try to go ahead and graph your parent function on there. Because then once we know our parent function, we can move this thing up, down, left, right, whatever way we want to go. Do a little dance with the thing. All right, so this -1, notice how that -1 is with your x's? So that will move everything, remember do the opposite when you're with the x's, to the right one. This +2, since it is not with the x, it will change it in the y direction and move everything exactly as we see, so it'll move everything up 2. So now if I take this point, move it right 1, up 2, he is there. Also, this point, so right 1, up 2, so that point is there. And then the only other thing we need to move to help us graph this is our asymptotes. So if I had an asymptote at 0 and it moved to the right 1, I now have an asymptote when x equals 1. There's one asymptote. My other asymptote, I will have, because it moved up 2, it was right there when y was 0. If I move it up 2, it is now when y is 2. So there's our other asymptote. So then to graph this thing, all I need to do is get closer to my asymptotes in either direction as I go. Forever and ever. Beautiful. That's the graph I'm going to be looking for. All right, so like for the domain and range on this thing, I'm going to get a real thing. So for our domain, this is going from negative infinity, so all the way to the left, up until x is 1. And then it has a break, so I go from 1 to infinity on forever. For the range, I have everything from negative infinity all the way up until 2. So negative infinity to 2. And then it continues on from right here. So from 2 to infinity, it keeps going up. And if it asks me to state my asymptotes, my horizontal, the one that is going horizontal, just like the Earth is, kind of like the horizon. The horizon is the bottom part. So like if you were to look over the horizon and there were like trees and stuff, horizontal is kind of like the flat line. It's our x direction. So we would have y equals 2 because it moved up 2. For our vertical asymptote, it's whatever x equals. So x equals 1 because it moved to the right 1. All right, Look at another one of these. So once again, my parent function is 1 over x. So for this one, this minus 2, this is going to move everything to the left 2. This minus 3 right here, or sorry, that plus 2, do the opposite with your x's, so left 2. That minus 3 moves everything down 3. So I will take all of my points, move them left 2. So I'm also going to be moving my asymptote left 2. So I'll have an asymptote here, and an asymptote there. Well, that's the same asymptote. And then down 3, so from 0 it goes down 1, 2, 3. So I know my points down 3 over 2 there. And I move this point down 3 over 2, so there. And it will get closer to our asymptotes as we go in either direction. Beautiful. Yes. All right, this is the last type of problem we are going to look at. Essentially, what this is giving us is it's giving us a parent function. It says write the equation for the translation of this function, y equals 2 over x, that has the given asymptote. So we know this is a rational, and rationals, if you remember for me, have asymptotes at 0 and when x is 0. So essentially what this is saying is starting off with 2 over x, how can I make an asymptote of 0 and an asymptote of 2? So I need to have some function that has asymptotes at 0 and an asymptote when y is 2. Well, if x is 0, then that means it didn't move left or right, so I won't do anything in my denominator. I won't add anything down here. But if it moved up 2, then I must have a plus 2. Well, hey, there's our function. Yes, we did it. And in this one, we have asymptotes at -1. So my x is -1, I have an asymptote, and when y is -2, I have an asymptote. So I have asymptote and asymptote. So notice, the x asymptote moved to the left 1. So what that means is with my x, so y equals 2 over, with my x I need to move left 1, so I need to have x plus 1 in there. It also moved down 2, so outside of that I will have -2, and that is my function. All right, please, please, please come ask me questions. I'm here to help you guys. Love you guys. I'll see you all soon. Boop.